started it. I hope you at least maybe looked at it. But if not, I'm going to go over it with you from review B, and then you can look at review A to help study for tomorrow's test. Okay? So number 11, if you have it in front of you, you can look at it. But it says, for the following equation right here, find the domain and sketch the graph. So again, it's a square root. And remember, for a square root, the domain, it doesn't matter what's outside the square root. It's just the domain is not allowed to be, the square root's not allowed to be negative. So what you do is you set that, you could even leave the square root on it if you want. Set the square root greater than or equal to 0 and solve it. Or a lot of times you get the domain by just looking at it. I'm just going to leave this. Because you'd be like, oh, -2 is what makes that equal 0, right? And so that's why my domain is -2 to infinity. And then I kind of sketched over here to remind you what the square root of a graph looks like. The square root of x starts at 0, 0. When you plug in 1, you get 1. When you plug in 4, the square root of 4 is 2. It's kind of that half of a parabola on its side. This is where all the transformation rules that we've talked about all year, if you remember those, when you see a negative in front, what does that mean? It means it's flipped over the x-axis. So that's why my graph is going the opposite way. When it's added 2, that means it's moved back 2 or left 2. And the -1 means it's moved down 1. And so if you know the transformations, you might be able to make the graph a little bit easier if you don't. But also you can make an XY chart, but you can't pick an X that's not in the domain. So if your domain starts at -2, make sure you start your XY chart at that domain value. And then pick other points. You have a calculator, so you can pick whatever you want that's bigger than -2. I try to pick numbers that give me perfect squares, so I don't have to graph decimals, but you can graph decimals. But notice I picked -1, because -1 plus 2 would be 1. And then I'd have a -1 minus 1, right? Like, so I would just get -2. So I picked numbers that gave me perfect squares, but you can pick whatever you want, type it in your calculator, and get the decimal. Looking for the shape here. So I think 3 points is a good amount to draw. So here is kind of a big point. It doesn't keep going. It stops at -2, 1, because that's where the domain starts. And then it's the bottom half of that sideways parabola. So it's going to the bottom because of that negative right there. And again, there's one on review A that you could go and do now that's kind of similar to that. Questions about that? And I'm going to post this, so if you don't get it written down before I go, just know that I'll have this posted, and I'll also post the video if you need to go back and listen to it again. Number 12 is a piecewise function, which we also did very early on in the semester. Piecewise functions always stress people out because they look scary, but remember, it's just more than one equation graphed on the same graph. So remember that this part here is just breaking your graph up. So you don't have to do this, but for me, I always put dotted lines on my graph to break that up. So at -2, I put a dotted line. At x equals 0, which is the y-axis, I put a dotted line. And at 3, I put a dotted line. And then you have to graph each part in that little section. So for -2 to 0, that's this section right here, I'm going to graph the linear equation 1 minus 2x, which is just slope-intercept form, right? Y equals mx plus b. So the y-intercept on that is 1. So at 0, it's at 1. It's not included, so that should be an open circle at 1. And then I just did the slope, which is -2. So I would go up 2, back 1, up 2, back 1, and it stops there. You don't have arrows because it's only defined between x equals 0 and x equals -2. So it's really just like a line segment. Open circle if it's not included, like at 0, closed circle if it is included. And then the same thing for x squared. We know what x squared looks like. It's a parabola. But I'm only allowed to graph it where it's defined, from 0 to 3. So at 0, it's 0. If I put 1 in there, 1 squared is 1. If I put 2 in there, 2 squared is 4. And if I put 3 3 squared is 9. So I had to make my graph go up to 9. But notice it's not included. So I should have an open circle there. And so it's just that 1/2 of the parabola only defined from 0 to 3. And then the last one is just a number. And remember, like y equals -6. That's just a slope of 0. So it's just a straight line at -6. But because it's a piecewise function, this tells me I can only start it at 3 and go this way. This is the only one that has an arrow on it because it's the only one that keeps going. Both of these were defined, like restricted. And again, there's one like this on part A. And even if you struggle with it, do something, draw the line, show me that you can do a little bit of it to get some partial credit because, you know, that partial credit can add up even if you don't get the complete right answer on it. Questions on that one? All right. Number 13 says, express the following function in vertex form, and it gives you vertex form. F of x equals a times x minus h squared plus k. We've done this more recently. And then it says graph the function. So 2 ways to do this. One way to do this is to complete the square, which is what I did over here. So remember, if you complete the square, that means you have to factor out the 2 first. So from here, I took the 2 out, and I got x squared plus 4x. And then I have to complete the square. This is the part I have to fill in. So I take half of 4, and I square it, which is 4. So I add 4 here. But to keep it balanced out here, it's not really just subtracting 4 to undo it. It's 4 times 2. So that's why out here I subtracted 8, or I subtracted 4 and then multiplied by the 2 in front. And the reason we do that is because then we can write it as a perfect square. When we did this, I showed you 2 ways to do it. The completing the square way, but I also showed you that, remember that h is just equal to -b over 2a, using the ax squared plus bx plus c. So if you want, if you're like, I don't really get the completing the square way, remember that you can just do -b over 2a, and you get that h is -2. And then to find k, you just plug h into the problem, and you get the k value, which is -5. And then you just have to plug it back into your equation. So I just wanted to remind you that we did this 2 ways. I showed you 2 ways of doing it. So you just have to see what makes sense to you. But the idea is, if it's in vertex form, it's not so bad to graph, because the vertex is h and k, remember? So the vertex would be -2, -5, because remember in the formula it's the opposite sign of h. So -2, -5, and the 1, 3, 5 rule is what I use. But since there's a 2 in front, instead of going over 1 up 1, I have to go over 1 up 2. And then normally I go over 1 up 3. Oh, I think I kind of messed that up, right? Because the next one would be over 1 up 1, 3, 5 would be up 6. So it'll be over 1, 1, 2, 3, 4, 5, 6. I think that should be like that. No wonder I was struggling. 1, 2, 3, 4, 5, 6. So it should look like this. Worst case, if you don't know how to put it in vertex form, 1, that's worth some points, so you're not going to get full credit. But you could just make an XY chart and pick some points, and you could make the graph as well, and you could still get some credit even if you don't put it in vertex form. Or you could put it in vertex form and not graph it. These questions are worth a lot of points. So again, my biggest advice to you is try to do something to get some partial credit. Okay, 14, I took a whole piece of paper on to do 14. So first of all, 14 gives you 2 rational functions, 2 fractions, and they ask you to do 3 different things and to give the domain of them. So first of all, it just says find f minus g, which just means subtract the 2 functions, but they're fractions, which means that you have to get a common denominator. These 2 functions have nothing in common. So the common denominator is just taking x minus 7 and taking x plus 4. We did some of this when we solved these equations. This one we're not solving, we're just trying to put it together. So how did I get a common denominator? I said I need x minus 7 and x plus 4. So you have to multiply the numerator by what's missing, right? Just like if I did 1/2 plus 1/3, if the common denominator is 6, over here I'd have to multiply by 3 because that's what's missing, and I'd get 3/6. And over here I have to multiply by 2. It's like multiplying by the other one. So that's why over here I multiplied by x plus 4 because it was missing to make my common denominator. And on this one I have the x plus 4, but I'm missing the x minus 7. So to make my denominator work, I have to make it match on the top of what's missing. And then I never touch the denominator. Like, you can work it out if you want. But the numerator, we can distribute out, and we can combine like terms. So then I just distributed my x's. Watch my negative sign. And then I left my answer like this. Negative 2x squared plus 25x over x minus 7 and x plus 4. If you distributed it out, that's okay too. And then it says give the domain. So this is why they give you fractions. Because if they gave you lines or parabolas or any polynomial, the domain of those is all real numbers. And they want you to really think about domain restrictions. And so the easiest thing they can give you to make you have to think about domain is fractions. So when you're writing your domain of these, you have to think about the domain of the original problem along with the new problem. Well, the good thing on this one is the denominators here are the same as these denominators. So x can be anything except for what makes these go to 0. And I thought that they would make you write them in interval notation, but then I looked at the answer and they accepted either way. So that was really nice. But my domain here is skipping over -4 and skipping over 7. So it's like 3 parts. But this would be a much easier way to write the domain, right? The domain is just x can't equal -4 and 7. And if you look at the answer key, they say both of those are acceptable. So I say just write it the easier way. Also on 14, it says find f divided by g, which I thought was very similar to one that we had on last week's test because you get a complex fraction. So I didn't show my work very well. But if I did f divided by g, that would be x over x minus 7 divided by 5x over x plus 4. And I'm just going to go ahead and write it as a division sign instead of a fraction bar. And then just like last week, we talked about copy dot flip. When you divide with fractions, it's the same as multiplying by the reciprocal. And on this one, you can cancel out a little bit, not much. You can break up multiplication. You can't break up addition and subtraction, but you can cross out an x on the top and the bottom here. And then just all that's left on top is x plus 4. And then all that's left on the bottom is 3 times x minus 7. Or again, if you really want, you could write that as 3x minus 21. The domain has to be the restrictions here along with the original restrictions, which means I think we're still skipping over 7 and -4. But you also have to skip over 0. And why is that true? Because when we did copy dot flip, we then have this x in the bottom. And even though we canceled it out, it's still not part of the domain. We talked about this for last week. If you cancel something out, that's a hole in the graph instead of an asymptote, but it's still a discontinuity. So you have to kind of look through your problem there and check to see if there's anything else that gets canceled out. And so I wrote this out like this, and then I checked my answers, and I went back and just said, oh yeah, I'm totally just writing it like this. And then 14 had a third part. It said, find f of g of x. That's with the open circle. So we did this as well. We even did one with a fraction like this. When you do f of g, remember that means whichever one is second goes into the first one. It's not multiplication. It's like going into the place of x. So this is your first step, right? F of x was x over x minus 7. I have to take what g is and replace each x with that whole quantity, that whole fraction. And you get a crazy looking fraction like this. 3x over x plus 4 over 3x over x plus 4 minus 7. And you kind of have a multitude of options here of how to solve this, but I tried to pick the way that I thought would be the easiest. A fraction and a fraction is kind of a big mess, but since they both have the x plus 4 in the bottom, I thought the easiest way to get rid of that a little bit is what if I multiplied everything in the top by x plus 4 and everything in the bottom by x plus 4, because that's just multiplying by 1. And so look what happens. This cancels out with this, so I'm just left with 3x here. And then this x plus 4, I have to do it times everything here, but this x plus 4 cancels out with this x plus 4, so I'm just left with 3x. But over here, nothing cancels out, so I was still left with the negative 7 times x plus 4. And I know that's not great, but to me, this looked way easier than dealing with that one. And so that's another way that you can deal with fractions. You could just get a common denominator. And then what can you do? You cannot cancel these out, right? Because of the subtraction, don't do that. But what you can do is distribute the negative 7 minus 28. And I think this is the answer that the book gives you. That's a lot of crazy work. This was about the time last night I was like, this is a lot of work. We also talked about the domain of this. It was one day in here. I'm sure you don't remember because, you know, we've done a lot. But when you do the domain of f of g, definitely you have to consider the domain of your new function. So if you say, what can't x be in here, and you set that equal to 0, you would get that x can't equal negative 7. Because if you set that equal to 0 and you add 28 and you divide by negative 4, you get negative 7. And you also have to take into consideration of the domain of the inside function only. So not of f, but only of g. So looking at this, I also have to include negative 4 as not part of my domain. That was a crazy amount of work for one problem. So they could ask you to divide, they could ask you to subtract, they could ask you f of g, they could ask you more than one. And again, there's a lot of steps there, and there's a way to get some partial credit, even if you don't get all of it, but there's a lot to do. 15. 15 asks you to sketch the graph of this, and it also says find where f of x is greater than 0 and where f of x is less than 0. So first of all, this is a polynomial function. We talked about polynomial functions in chapter 2, part 1. We talked about their multiplicity. We talked about their degree and their leading coefficient. So notice before I even graphed anything, this is factored for you, so you can find the zeros. And remember that exponent gives you the multiplicity. And if it's an even multiplicity, it only touches the x-axis. And if it's an odd multiplicity, it crosses. So at 0, there's a multiplicity of 2, which means it touches. This one would equal 2, and it has a multiplicity of 3, which means it crosses. And not only does it cross, it crosses at like a squiggle, right? Like x cubed. Negative 1 has no multiplicity, or you could say multiplicity of 1. And that one's just going to cross, just like linear. And then negative 4 has a multiplicity of, did I say 4? I think that should say 2, right? Did I write that wrong? Or it's 2? Yeah. Which means it also just touches. What else can I tell? Well, if you add up all the exponents here, remember there's a 1 here, you get 3, 4, 5, 6, 7, 8, which means it's a degree 8 function, and the leading coefficient is negative, which means I know both arrows point down. So I can tell all of that by just graphing this. The thing about this is giving you such a big polynomial is the y values are going to be really crazy. And if you looked at the answer key that they give you, they don't even acknowledge what the y values are. They do the x-axis, and I'll say the same thing is true for me. For the most part, I'm focusing on the x-axis, and I tried to kind of pay attention to the y values as it was going here. But the first thing I did before I even picked my y values is I graphed my zeros. There's a 0 at 0, there's a 0 at 2, there's a 0 at negative 1, and there's a 0 at negative 4. I know both arrows point down, so I can make, like, I know that part, that they're both going to point down, and I even know about touching or crossing, but you're going to have to get a few points for this. So if I go down here a little bit more, the thing is you get crazy numbers, right? You get, like, at 1 it's 50, but at -3 it's -2,250. So you could try to make your graph go by like 500s or 1,000. I tried to, like, I had stuff here. I was going by like 500s. But then I looked at their key and they didn't even label the y-axis, which means that as long as you're in the general vicinity, it's more about making the graph look like it's supposed to look at the x-axis. So I kind of made some points here. If you want to label this, you can. But using what we know, this has a multiplicity of 2. So I know that the in behavior is pointing down, and then it's just going to touch and go back down. This one has a multiplicity of 1, which means I know it goes straight through. This one has a multiplicity of 2, so I know that it comes back down and touches and goes back up. And this one has a multiplicity of 3, which means I didn't make it go straight down. I tried to make it kind of go at a curve to sort of look like a multiplicity of 3. And if you look on the answer key, it says this is only a sketch, which means really focus on touching or crossing and your x-axis, and you don't have to stress a whole lot about the y-axis values. But then it says, where is f of x greater than 0? F of x is y. So where is y greater than 0? Everywhere that it's above the x-axis, right? So you can look at this and see that it's above the x-axis between -1 and 0. And where is y positive? Between 0 and 2. And then where is f of x negative, less than 0? Where is y less than 0? Well, all these places that it's negative values, right? And so up to -4, and then from -4 to -1, and then from 2 to infinity, it's going to be negative from there. And again, there's one on review A that I think you can go back and look at. That's worth a good amount of points. So again, trying something, showing me the multiplicities is going to get you some partial credit. And then the last 4 are all about chapter 2, where we solve polynomials using PRZs and using division. Number 16 says, find the quotient and the remainder. And you might say, well, why didn't you do synthetic division? Because synthetic division only works if you're dividing by a binomial, by an x to the first power. And they gave you an x squared to divide into an x to the fourth, which means that you have to do long division on this. Which means there's a whole lot of room for error in terms of messing up negative signs, but please try it and show your work. Remember, you start one step at a time. You say, well, 1, notice I filled my zeros in. Whether it's long or synthetic division, remember, if it skips over an exponent, it's going to be easier if you fill those in. And then you say, what multiplies by x squared to give me 3x to the fourth? And you start right here with that first number. Because 3x squared times x squared gives me 3x to the fourth. But where do I get all these? Because you have to multiply by the whole thing to get those numbers. And then remember, in division you subtract, and that's where our mistakes tend to happen, and you bring down the next number. And you have to do it 3 times, each step getting the next number to do that. But on your test, they give you a question like this, and there's just a space that says quotient, which means that this is the quotient, it's the answer that you get, and this is the remainder, and they just have you leave it like that. Like you just write it as 18x plus 52. What do you think about that? My advice is, if you haven't tried this one, to maybe try it first, because then you can go back and check your answer step by step. Whereas the one on review A, you're only going to have the final answer. This one, you're going to be able to check line by line to see if you messed signs up, is my advice. Solving polynomial equations. You can do PRZs every time, but remember, if you can factor, Or you can do GCF, factor by grouping. Those are ways that are going to be faster to do. So like on 17, there's 4 terms here. I grouped them together to see if I could do factor by grouping. Could you have done PRZs? Definitely. But to me, this is faster than PRZs, if it works. So I factored out an x squared here, and I got x plus 3. On this one, I factored out a negative 16, and I got x plus 3. If these two are the same, factor by grouping works. If they're not, you have to do PRZs and synthetic division. But if you can do that, you pull out the part that's the same, put this together, and these were all very nice rational zeros. No quadratic formula needed, no imaginary zeros, just factor by grouping. Number 18 is another example. It's not factor by grouping, but it's GCF, greatest common factor. All of these share an x squared, so I could pull the x squared out, and then look what's left. It's just a quadratic, and if you want to do the quadratic formula, you can. But again, this one you can factor, and you can't get plus or minus 0, so you just get 0 here, but then you get negative 4 and negative 5 as your answers as well. So those are nice reminders that not everything is a PRZ question. Also, make sure you read the directions, because number 19 just says list the potential rational zeros, not find them. So your whole answer on 19 is just listing out the possible rational zeros. And so remember, the rule for that is it's factors of the last number on top. Factors of 24, there's a lot. 1, 2, 3, 4, 6, 8, 12, 24. And on the denominator, it's factors of the leading coefficient. And on this one, it says list them. So I need you to list all the possibilities. So all of them include all the whole numbers up through 24. But then you have to put everything over 3. So 1 over 3 is 1/3. 2 over 3. 3 over 3 is 1, so you don't have to list it. But 4 over 3 and 8 over 3 are the other ones that are listed. And that's it. That's the answer to 19, is just listing them out. So maybe, like, if you're struggling on the test tomorrow, go do the ones that, like, maybe don't have as much work to do. Get those points done so you don't run out of time on some of the ones that, you know, taking too much time on some of the other ones. And then the very last one actually says solve it. And so that's where you're going to have to use your PRZs and find the answer, okay? And so again, I'm going to go ahead and skip to number 20, but I promise I either have this posted already or I'm going to post it. That number 20 says solve. And you could try to do factor by grouping, but it's not going to work because 23 is a prime number and nothing's going to factor out of it. So that's why I didn't even try it, which means I have to do PRZs. It's my only option. So notice the first thing I did is I listed, there's a lot. Everything over 30 over everything over factors of 3. And then I just started trying them, hoping that it was going to be 1 or 2 or a small number. So remember, what does that mean? It means when you plug 1 in here, you're checking to see, does it equal 0? And notice, I didn't even put what it equals. I was just checking, and in my head, I was like, nope, that doesn't equal 0. And then for 2, I put it in my calculator, and I had to go through and plug in 2 for all of that, and it did equal 0. So one of my answers is x equals 2. And then what do? I synthetically divide it out, and I should get a remainder of 0. And I write what's left. Since this was x to the third, I'm left with 3x squared minus 4x minus 15. And I didn't even try to factor that because there was a 3 in front, and I thought it wasn't going to be factorable. So I just did the quadratic formula, and it turns out it was factorable. And so doing the quadratic formula and working out both my answers, I got 5/3 and negative 3 and 2 as my answer. I definitely think that this has a lot more stuff from the more beginning chapters in this class. And I also think some of these questions have a lot more work than what we did on last week's part of the final. But again, just like on last week's part, you're not going to be surprised what questions you see because they're going to look just like this. It's just whether or not you know how to do them, right? Whether or not you have it done. But I think if we go here to, what I posted today. One, I posted my answers I just went over. I'll also post this video. I also posted review A in case you've misplaced review A. Review A, if you skip over here to day 2, these are different questions than the ones I've gone over if you want to go and practice them. If you haven't even done review B and you want to go back and practice those because you have the work to go with it, you could do that as well. But I can't stress enough that you should probably try to look over some of these so that you can do well in the final tomorrow. Okay? You don't have to turn anything into me tomorrow. You just got to come in, use my calculator or have your own calculator, and then you'll take your final. Okay?